Dear my friend, welcome to this video. In this video, we will introduce to you that how we can make point addition or for points on the elliptic curve. So let's see how we can define the addition. Giving 2 points on the curve, for example, point A on the curve, point B on the curve. So how we can define the point A add to the point B? So let's do this. First, we connect A and B with a line, right? With a line here. Then we extend the line to make the line to intersect with the curve on the third point C. Now, given C, we find its symmetric point over the x-axis. That is this point, right? So this point we define as A plus B. So we do such kind of operation. First, we use a line to connect the points A and B on the curve. Now, extend the line to the third point that intersect with the curve, and find its symmetric point over the x-axis. And that symmetric point of C is the result of A plus B. Here is a definition of A plus B. So the same applies to B plus C. For example, giving 2 points B and C here, right? So when we do B plus C, we use a line to connect B and C. Now extend the line to intersect with the curve on the point of A, right? And then find the symmetric point of A over the x-axis. So here we may find a point here, right? Lowly the point here. And this point here, we can define as B plus C here, right? So B plus C should be the point A, and find its symmetric point over the x-axis. So it should be here, right? And the same applies to A plus C, right? The A plus C, then we use a line to connect A and C. Now we don't need to extend the line because the third point B is intersect with the curve. Now we find the symmetric point of B here, right? Come to here, find its symmetric point here. Then this point here can define as A plus C. So you can see this addition has this property, right? The commutativity has this property, commutativity. So A plus B is equal to B plus A, right? A plus B is equal to B plus A by our addition, by our definition of addition, right? No matter you use B to plus A or A plus B, we always get this point, right? So it has the first commutativity property. Now let's see its another property we call associativity. So associativity is like this. When we have 3 points add together, we can add the first 2 points, then using the result to add the third point. Or we can add the second and third point, and using the result to add with the first point. So let's see here that this is the image of A plus B, and then use the result plus C. So let's see A plus B. So the third point is here, right? A plus B, the third point is here, because this point intersects with the curve on the third point. So we find its symmetric point here. So this point is A plus B. Now we can connect C with this point. Now and extend the line to here and find its symmetric point here. Find to here, right? So this is the A plus B and then plus C, right? Let's see another one. Let's see the image of this one. Let's see the image of this guy. So here is the image of this guy. Right, first we have 5B plus C, right? Here, the third point intersect with the curve here. Now find its symmetry. Come to here, it's B plus C, right? Now we connect the A with the B plus C here. So this yellow line here. And we extend the line to here. And so we find the symmetry of the third point. Now it comes to here, right? So these 2 points, so the result is the same, right? The result is the same for this one, right? So when we do this one first, and the result is the same for this one. So that's we have the property of associativity. So this is the second property of the addition. And finally, we have a special case. When the point A and B are on the same vertical line, for example, A here, B here, then when you connect A and B together, and no matter how you extend the line here, you can't find the third point that can intersect with the curve, right? Because you extend the line here, you will go up and go down, and there's not possible that there is a point can intersect with the curve. So there is no third point that can intersect the curve like this case. Now here is we go to the we need to burn some brain cell. We define the no existent point as the identity of the as the identity. So we give a concept for this third point. I, we call it identity point I. So here actually this point never exists, right? Because we don't have the third point that can intersect with the curve. But we still give this non-existent point a name called identity point I, and define the addition for this point like this. For any point P on the curve, it plus with the identity point equal to itself. So this is totally defined by on the concept. It's not on the curve, but we define it on the concept. So we have an identity point here. An identity point is the third point that never exists. So if when we use code to when you use code to implement this identity point, we will set its x and its y component to none. So when one of its x or y is none, or both of its x or y are none, then we will say this point is identity point. Yeah. Okay. This is all the basic knowledge about point addition on elliptic curve. And in next video, we will see how we can use curl to implement the point addition here. I will see you in next video. Bye bye.